Hi, I'm Michelle, and in this video, we are going to be discussing a counting technique called stars and bars. So what is this technique, and when is it used? Let's find out using an example. We have 5 identical candies, which we want to split among 3 friends. How many ways are there to do this? Well, one way we could solve this problem is by doing casework. But what if there are 100 candies and 10 friends? Then there would be far too many cases to handle. Instead, we can use the stars and bars method to quickly and easily solve any problem where we distribute n objects to m people. So going back to the example, let's consider a distribution of the 5 candies into 3 groups corresponding to the 3 people. Let's call the people A, B, and C. This is equivalent to placing the 5 candies in a line along with 2 dividers. For example, in this arrangement on the screen, A gets the candies before the first divider, B gets the candies between the dividers, and C gets the candies after the second divider. So A gets 1 candy while both B and C get 2 candies. We can see that each different way to distribute the candies corresponds to a different rearrangement of the 5 candies in 2 dividers. This idea is called stars and bars because we are using the rearrangement of dividers or bars to separate the candies or stars. Now, in order to count the number of distributions of candy, we just need to count the number of permutations of the 5 candies and 2 dividers. There are 7 spaces in total, and we can choose 2 positions for the dividers and fill in the other 5 spaces with candies. In total, there are 7 choose 2 ways to rearrange the 5 candies and 2 dividers, so there are 21 ways to distribute the 5 candies to 3 friends. In the general case, we can follow the exact same steps to show that there are n plus k minus 1 choose n ways to distribute n identical items to k people. Stars and bars is one of my favorite math concepts because it's an elegant way to simplify a problem that might otherwise require extensive casework, and it shows up in so many different problems where you might not expect it to. So now let's go through a couple of examples of cases where stars and bars might be used. Example 1. Find the number of ordered quadruples of non-negative integers a, b, c, and d, such that a plus b plus c plus d equals 20. We can see that this problem is equivalent to splitting 20 candies among 4 people. So using our formula, we get that the answer is just 20 plus 4 minus 1 choose 4 minus 1, or 23 choose 3, which is 1771. Now let's move on to something a little trickier. Stars and bars problems may be modified to have certain restrictions, such as in this example. How many ways are there to distribute 10 candies to 4 people such that each person gets at least 2 candies? At first glance, it's not clear whether stars and bars can still be used with this added restriction, but it turns out there's actually a simple way we can convert this into a regular stars and bars problem. We can set aside 2 baseline candies for each of the 3 people and count the number of distributions of the remaining 4 candies using stars and bars. We have 4 candies with 2 dividers in a line to decide how to distribute the extra candies. In the example on the screen, A gets 1 extra candy in addition to the 2 candies originally set aside. B gets 3 extra candies in addition to the 2 original candies, and C gets no extra candies in addition to the 2 original candies. Sorry, C. Now we just need to count the number of ways to rearrange the candies in dividers. In total, there are 6 slots, of which we choose 2 for placing the dividers. So the answer is 6 choose 2, which is 15. Now I have a challenge problem for you. You might encounter disguised stars and bars problems that require a little more thinking, like in this example. How many ways are there to choose 4 integers a, b, c, and d from 1 to 20 inclusive, such that a is less than or equal to b, which is less than or equal to c, which is less than or equal to d? Well, we can use a change of variables, so we can use the stars and bars method. Let b prime equal b minus a, c prime equal c minus b, and d prime equal d minus c. I'll leave it to you to think about how to solve this problem. Thank you so much for watching, and I hope you learned something from this video.